This is Eureka Math. We are in Module 6. This is Lesson 8. And our objective today is to generate a number pattern for a given rule and plot the points. Now, yesterday we did this a little bit, but today we're going to explore the idea a little bit more, creating rules for lines. Okay, so let's go to a problem set. Please write your name on your paper. And number 1, create a table of 3 values for x and y such that y coordinate is 3 more than the x coordinate. So here's our rule. It's going to be x, plus 3 equals y, okay? So if we make x the number 1, we're going to put that x in our rule here. X plus 3 is 4. Okay? So our coordinates would be 1, 4. Next one, if we make x 2, 2 plus 3 would be 5. That would be 2, 5. And if we make x 3, 3 plus 3 would be 6. And 3, 6, okay? So each y coordinate is 3 more than the x coordinate. Does that make sense? So 3 more is 1 plus 3 is 4. 2 plus 3 is 5. 3 plus 3 is 6. Plot each point on the coordinate plane. So 1, 4, 2, 5. Wait a minute. Oop, wrong. 2, 5, 3, 6, okay? So those are points. Use a straight edge to draw a line connecting these points, okay? Just like that. Now, give the coordinates of 2 other points that fall in the line with x coordinates greater than 12. You know, let's just do a couple more. 4 and 7 and maybe 5 and 8. So that would be 4 and 7 would be here. And 5 and 8 would be here. So it would just go like this direction, right? Just so we can see where that line is going. Okay. Give the coordinates of 2 other points that fall on this line with x coordinates greater than 12. So, if we make the x coordinate up here, 13 maybe, 13, well, what would the rule be? 13 plus 3 would be 14, 15, 16. So 13 and 16 would be up here. Ooh, it's even beyond the page there. 13 and 16. Can you see that this would be still in the straight same line? 13 and 16. And let's say 14 and 17. That would be here and here. Okay. So that line just keeps going if we follow that same rule. Next one, create a table of 3 values for x and y such that the y coordinate is 3 times as much as its corresponding x. Okay, so x times 3 equals y. Okay, x times 3. And actually, when you get a little bit more professional, you can just go 3x. When they're stuck together like that, that means multiply. Okay, so if we pick something like 2 as our first number, well, let's go with 1. 1 times 3 is 3. 2 times 3 is 6. And 3 times 3 is 9. So that would be 1 third, 1 and 3, 1 and 3. And then this one would be 2 and 6. 2 and 6 here. And then here we have 3 and 9. So 3 and 9. And this line goes really straight up, doesn't it? Okay, so we plotted our coordinates, we drew a line to connect them. Now if we give coordinates of two other points that fall on this line with y coordinates greater than 25, the y has to be 25. Okay, so let's say x times 3 equals greater than 25. Let's pick 30, okay? How are we going to find that? Well, what we could do is divide this side by 3 and divide this side by 3. And that would make this number go away and this number go away. And that would make x equals 30 over 3. Well, you could pretty easily take that and make it 10 over 1, which equals 10. Okay, so if our y-coordinate is 30, our x-coordinate is 10. So let's do that. 10 and 30. So here's 10. It would be all the way up, well, beyond this page, all the way up here somewhere, right? And let's see, another one. How about How about 33? X times 3 equals 33. So what we would do is we would divide this side by 3 and this side by 3. And here we would delete that, and this would turn into 11, right? So x equals 11. And if x equals 11 and y equals 33, then that one would be way up here, right? Good. All right, number 3. Create a table of 5 values for x and y such that the y coordinate is 1 more than 3 times as much as its corresponding x value. Okay, let me think about this. The y-coordinate, oh, this is a hard one. Okay, you have to read the English very carefully. The y-coordinate is 1 more than 3 times as much as its x-coordinate corresponding. So x times 3 plus 1 equals y. Okay, so the y-coordinate is 1 more than 3 times as much as x. So x times 3 plus 1 equals y. That took me, I had to use my brain on that one. Okay, so let's try. If we make x 1, 1 times 3 is 3, plus 1 is 4. If we make x 2, 2 times 3 is 6, plus 1 is 7. If we make x 3, 3 times 3 is 9, plus 1 is 10. If we make x 4, 4 times 3 is 12, plus 1 is 13. And 5 times 3 is 15, plus 1 is 16. So 5 and 16. So now our coordinates would be 1, 4, 2, 7, 3, 10, 4, 13, and 5, 16. And I'm just going to go get my book and see if they used those same numbers in our book. I just want to check. Okay, this is module 2. No, wrong book. Module 6. There we go. Okay, and this is lesson 7, right? Lesson 8. Just want to see what they did, because I want to make sure that I am following how they did it. Ha-ha! Look at us. We are being very successful today. Very good. Very good. Okay. Yes, that is exactly how they did it. Great. So plot each point on the coordinate plane. 1 and 4. 2 and 7. 3 and 10. Wait a minute. 4, 8, 9, 10. 3 and 10 here. 4 and 13. 5 and 16. Okay. That's why you need a ruler to keep things straight. Good. Give the coordinates of 2 other points that would fall on this line whose x-coordinate is greater than 12. Okay, well let's do 13 then. 13. So 13 times 3 would be 39, plus 1 would be 40. This obviously doesn't go to 40, but it would be somewhere around here. And if we follow that straight line here, it would be all the way up here somewhere. Okay. And the next one, let's do 14. 14 times 3. 72. Wait a minute, is that right? First of all, 13 times 3 is 9 and 3. Plus 1 is 40. Okay, 14 times 3 is 12. Carry the 1 is 3 is 4. That's what I did wrong. I know I was doing something wrong. And then plus that 1 is 43. So 14 and 43. Okay. And that would be all the way up here. Excellent. Number 4, use the coordinate plane below to complete the following tasks. Graph the lines on the plane. Okay, so we're making lines. Line L. X is equal to y. X equals y. So whatever number we pick, it's going to be the same. 5 and 5. 8 and 8, 10 and 10, okay, equal, they're equal, so 5, 5, 8, 8, 10, 10. If you want to use different numbers, go ahead. Let's plot that line here, and here, and here, and let's see, we've got 1 and 1 there, let's see, that would make that line look just like this. It just keeps going, and we're going to call that line L. Okay, M, y is 1 more than x. Okay, so that makes x plus 1 equals y. X plus 1 equals y. So 1 plus 1 would be 2. I'm going to use a different color. Sorry, let me switch the colors out here so you can see the line in a different color. And let's see. Let's try 2 plus 1 would be 3, 5 plus 1 would be 6, and 10 plus 1 would be 11. Those are just random numbers I picked, but as long as I add 1 to make the y, 2, 3, and 5, and 6, and 10, and 11. So 2 and 3 would be here, 5 and 6 would be here, and 10 and 11 would be here. Look at that. That line looks an awful lot like it's like the other line. They, in fact, look to me to be parallel to each other. Ooh, look at that. And that one we're calling line M. Okay? Ooh. Now, y is 1 more than twice x. So x times 2 plus 1 equals y. Okay, so if x is, let's just make x 1, then 1 times 2 would be 2, plus 1 is 3. 1, 3. Let's say if x was 5, 5 times 2 is 10, plus 1 is 11. So 511. And then here we have, let's try 10. 10 times 2 is 20, plus 1 is 21. Okay. So 10, 21. And I am going to change colors again. I should have changed it right away. I'm sorry, I didn't do that. Green. Okay. So 1, 3, 1. 1, 3. 5 and 11. 10 and, well, 16, 17, 18, 19, 20, 21 would be all the way up here. So let's pick something that's still on the board, huh? How about, well, if y were 15, that would make that 7, right? 7 times 2 is 14, plus 1 would be 15, so let's try that. 7 and 15 will be right here. Okay, so then draw a line on that one. And we'll call that one N. Good. Ooh, my hand's falling asleep. Which two lines intersect? Give the coordinates of their intersections. In fact, this one is going to intersect with that one. Let's make this 0. And 0 times 2 is still 0 plus 1. So 0, 1. So they are going to intersect right there, aren't they? Is that how they did that one? I'm going to double check. Oh yeah, sure is. Okay. So, and this one is N, right? So N is going to intersect with M. And the coordinates of their intersection would be at 0, 1. Do you see how they both land right there? Okay. And I can show you that here because if x up here were 0, plus 1 would be 1. Okay, so 0, 1, 0, 1, that's where they intersect. Which two parallel lines are parallel? Or, I'm sorry, which two lines are parallel? Well, that's pretty easy. M and L, we already looked at that. Give the rule for another line that would be parallel to the lines you listed in 4C. Okay, so if we want to make another parallel line, we could do it with y is 1 less than x. So if we did x minus 1 equals y, that would work, and we can show you. Let's go to orange just to show you that. Okay, or pink, red here. So let's see. If x is 0, no, that's a negative number. If x is 1, 1 minus 1 is 0, so it would be 1, 0. If x was 2, let's say if x was 5, 5 minus 1 would be 4. Okay. And if we did 10, 10 minus 1 would be 9. And then we could do 1 and 0, so 1, 0. Isn't that what we just did? 5. Oh, here we go. 1, 0, 5, 4, and 10, 9 would be all right there. Do you see how those all would be also parallel? Right? They all just keep going. That would be parallel too. You could call that line O. Excellent. Okay, there's your homework. More of the same. If you have some struggles with this, let me know. Creating rules it's often about reading what they're saying. Okay. So y coordinate is 4 more than the corresponding x coordinate. So x plus 4 equals y. Okay, so y coordinate is 4 more than x. Or you could write it like this, y equals 4 plus x. Okay, either way. How about down here? The y-coordinate is 2 times as much as its corresponding x-coordinate. So y equals 2 times x, or x times 2 equals y. Okay. And number 3, okay, it doesn't ask you for the rule. Okay. All right, and then your exit ticket, please read carefully. Y-coordinate is 5 more than 2 times as much as its corresponding x-coordinate. So think about that carefully. That's going to be your hardest part, I think, is to figure out what that rule is. Excellent, good job. Have a great rest of your day.